Hey guys, what's up everyone? Welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video, which is a part 2 upload to our previous tutorial on bearings application, in tutorial number 1 we had looked at the introduction to the concept of bearings, as well as went through some fine details as it relates to how to construct a question that is related to bearing and how to use the trig formulas, cosine, sine rule, and the trig ratios to deduce solutions based on the questions that were asked. So it's definitely worth having a look at. A link is provided in the description box below. And of course, if you're watching this video and you are tuning in for the first time, be sure to smash the subscribe button below, as tutorials are posted on a weekly basis that are related to a wide variety of math concepts, but specifically I focus primarily on the curriculum of the CSEC, SEA, CCSLC exams. All right, now in this particular tutorial, as I mentioned before, it's a part 2 upload, so we're gonna pick up from where we left off. This is example number 3. In the first tutorial we had done 2 very nice examples, and so it brought out a lot. Definitely tune into that. So we're just gonna go right ahead and jump right into this particular tutorial and this question here. All right, do not forget to leave a like, and of course leave your comments, suggestions, and video requests down below. Okay, so here we go. So we're going to start off with this very interesting question here. And in this question, we're going to be looking at the fact that a cruise ship sets out on a journey from Star City Harbor on a bearing of 310 degrees to Bright Light Harbor, which is 110 kilometers away. Now, a lot of the students that I have taught over the years tend to fluster themselves when you're reading the questions in full. And as I advised you in the previous tutorial, that given a bearings question that is as wordy as this one, you want to start attacking the problem from the very first couple of lines, if possible. All right, so you want to start constructing your diagram from the first few sentences that are given. So let's jump across to a blank page here, and we're going to be looking at the whole fact that we're moving from Star City Harbor to Bright Light Harbor on a bearing of 310, which is 110 kilometers away. So of course we're going to need a starting point. All right, and our starting point is obviously going to be at Star City Harbor. And so I'm just going to indicate perhaps here a starting point. Now, based on my experience, I would have already known that it is somewhere in this direction that my Star City, that Bright Light Harbor, would be located based on the bearing that was given. So I would go right ahead and I would just pretty much start with a north line, because as an object moves, a north line needs to be established. And then we're going to need a couple of guidelines that will eventually come in very handy later on in the question when it comes to dissecting the major angles or the major bearing. So because I'm dealing with a bearing of 310 degrees, I'm going to use up all my standard guidelines, which is the 90 degree guideline here. Okay, you don't need to indicate the 90 degrees here, but this is just for the purpose of the tutorial. My 180 degree guideline here, and my 270 degree guideline here. And I know that right away that my object, the cruise ship, would be traveling somewhere between 270 and 360. All right, so it's somewhere between here. Now, based on the first tutorial, we had looked at the fact that 315 degrees is the directional angle that lies between north and west. So 310 is not too far away from there. So we can just go right ahead here and kind of send our direction somewhere near in through the middle. So it's about here, not too far. Let me just give you a better drawing here. So somewhere in the center here, not too bad, right? So we're looking at this being 110 kilometers away. All right, so this is 110 kilometers. And what I find a lot during my face-to-face tutorials with my students is that they tend to either insert the 310 degrees at a wrong position on the diagram, or they simply forget to implement the 310 degrees. Now, as a reminder, we had said this in the previous tutorial, that when indicating a bearing, or you're drawing the direction given to you by a bearing, the bearing is measured from north and it is done in an clockwise direction. So it's from north coming around like so, all the way around until we meet up into the line that's taking us to our point. So it is all of that angle here that would be 310 degrees. Now, as you can see with those little blue guidelines here, it allows us to kind of dissect the 310 degrees into smaller portions. So you're going to find here that the angle here would have been 90 degrees. That's from north to east. I can now erase this here. You'll find that this also is another 90 degrees because this takes us from what? East to south. So I can now erase this here. And then you'd find another angle here of 90 degrees, which takes us from south to west. I can erase this here. And then therefore now this little piece of angle is going to come in handy a little later. So let's just find that angle from now. And this is how I recommend that you guys approach your bearings question. It makes no sense to draw the complete diagram and then go in search of those little pieces of angles. The moment you're at that section, just kind of find the related angles from now. Now, if the total angle is 310 degrees, total bearing, and we have already copped 270 degrees out of it, then that would simply mean here that 310 take away 270, and that would leave us with an angle in here of approximately 40 degrees. And then therefore we could actually find this remaining angle over here, which is also going to be 50 degrees because the total angle here is 90. All right, so that will come in handy later on, and you're going to see in a moment. All right, so this here, our starting point, let me just erase this 90, and we're gonna put right here for you that this is Star City Harbor. All right, and then here now is going to be Bright Light Harbor. All right, so that's basically the starting of that question. We're going to be attacking this next section of the problem now. So it says, after the first dispatch of passengers, it then continues to its final destination to Dark Light Harbor. So now the ship is currently at Bright Light Harbor, and it's going to end its journey at Dark Light Harbor. Now, Dark Light Harbor is 75 kilometers away, and that is on a bearing of 25 degrees. So let's see where that takes us. This is going to take us in this direction somewhere here. So what we're going to be doing here is that we're going to be establishing yet another north line, because as an object moves, then a north direction must be established by the captain. And so we're going to need another guideline here to our aid. So we're not really moving in a huge, like the bearing is not very huge, so we don't need a lot of guidelines. I only need this very exact guideline here. And so I know that my object will be traveling somewhere between here. Now I know that exactly between north and east here, as you would have known, is going to be exactly 45. So 25 is going to be more upwards, like in this direction here. All right, so we can perhaps just come here. Okay, let's just zoom it out a little bit. All right, let's just make a different line. That's 25 here. All right, we can just put it here. All right, and so this is going to be 75 kilometers away, and we want to make the diagram as realistic as possible. So we don't want both lines to appear to be the same length. So we definitely do not want them to be right above the north line, because that would kind of send a wrong message. So 75 kilometers away, not too much of a difference between the distance. So I'm just going to make that line a little shorter, guys, just a little shorter. Okay, so just here, about here. That's good. That's perfect. All right, and that is going to be approximately 75 kilometers away. All right, and then we had said that the bearing is actually 25 degrees. So just again, as a constant reminder, that our bearing is measured from north, coming around like so, and this is where our 25 degree is going to be indicated there. All right, so that is our 25 degree. All right, and so this is going to be dark light harbor, so we can just name that DL. Now obviously the ship is going to perhaps return to its journey here, so we are going to pretty much just come down like so and come back to our point here. All right, and that's going to be our diagram that represents this cruise ship journey. All right, so they're not very hard at all. I'm almost certain that you guys would have comprehended clearly how to attack the problem. So we've taken care of this section of the problem. Let's now have a look at what is required for us to find based on what we have drawn. It says use this information to calculate the distance from dark light harbor to bright light harbor. So dark light harbor to bright light harbor, dark light harbor to bright light harbor. So we need this distance here, because this is bright light harbor. So we are literally looking for the distance from here to here. All right, so let me just indicate just some smaller measurements here so that it's easier for us. So let's just indicate for you here our 25 degree. Let's bring it on the outside here, and then we're going to indicate our 75 kilometers right on the line here. Okay, that's good. All right, so what exactly are we looking for? We're looking for the distance of dark light harbor. I think I may have made an error in the typing. It wouldn't have been dark light harbor to bright light harbor, but it would have been perhaps, say, dark light harbor to Star City harbor. I think I made an error in the typing, so this would have been Star City harbor, because I would have already had the distance. As you can see here, if this was the actual question, I would have already known what is dark light to bright light. So I would have already known what is dark light, which is here, to bright light. I would have already known that the distance is 75. So there wouldn't be no point in me asking you to find that. So I think that the error occurred in the typing of the question. So it would have been Star City to dark light, or dark light to Star City. That would have been the actual question. Dark light to Star City. All right, so I do apologize for that. So we're looking for this distance here, from here to here. Okay, so how do we go about doing this? Clearly we are looking at a triangle that is non-right angled. All right, so far there isn't any indication of any 90 degrees that is within the diagram, so we are going to need to find some useful angles around. Now I did forget, as I mentioned to you before, once you have constructed a particular bearings direction, then what you want to do is also try to find some little pieces of angles in between. So I could have actually established the angle here, right, because from north to east is 90, and I already know that this is 25 degree, so therefore this would have been 65 degree. A portion of that angle is 65 degrees, right? So just by experience now, what we're going to be using is that we're going to be calling upon the formula of the cosine rule. And so the cosine rule is a formula we use to find the length of a missing side on a non-right angle triangle, specifically a scalene triangle. But the criteria that must be met for us to use the cosine rule is that we must be provided with two sides, which we do have. We have the 75 kilometers and we have the 110. But what we don't have is the angle that's between the two sides. We have a partial part of the angle, but we don't have the complete angle. So we're going to need to somehow find the remaining angle here, which is going to require our skills of geometry. So calling upon the whole principle of alternate angles, you can see that east here seems to be parallel with the west down here. So therefore what you're going to find here is an alternate angle being formed. And as I had mentioned to you before earlier, when we had just constructed the bearing surrounding Star City Harbor, you can see that this 40 degree that we had calculated here from early now seems to come in handy, because this angle now here is 40 degrees. So there you can see how handy it can be later on. Very useful in terms of what we need it for. So therefore the total angle inside here now, the total angle inside here is going to be a total sum of 40 plus 65, and that works out to be 105 degrees. So we're going to be utilizing that angle as we speak. So let's go ahead and use up the cosine rule here. We're looking at c squared. Let's zoom a little bit here. So c squared is equal to a squared plus b squared minus 2ab multiplied by the cosine of the angle between. Right? And so remember that c is representing the sides, or the side that we are in search of. So in this case here, c is going to represent the distance between Dark Light Harbor and Star City Harbor. All right, so I don't know what we can call it, x if you want to, or we can just call it ds, dark to star, or whatever the case is. We can just indicate this here with just a single letter to avoid the complexity. So we're just going to be calling this distance here. All right, so we're going to let distance between harbors be x. All right, the distance between the two harbors be x. So once we have calculated x, we would have calculated the distance. So then x squared, or you could simply just allow it to still remain as c, no problem. So x squared here is going to be equal to the distance known, which is obviously 110 squared, plus we're looking at 75 squared minus 2 times 110 times 75 multiplied by the cosine of the angle made by the two sides, which was calculated to be 105 degree. So we just grab our little calculator here and we're going to do some basic math. So 110 squared works out to be 100 and, or that's 12,100, my apologies. And 75 squared works out to be 5,625. So if you go ahead here and we multiply, say here 2 times 110 times 75, we're going to find that the answer here is 16,500. And if you find the cosine of 105 degrees, which you're expecting the answer to be a negative result, then it's going to be negative 0.259 rounded off, 259 rounded off approximately. Okay, and that's going to be x squared. So if you go right ahead here and we add 12,100 plus 5,625, we're going to find here that the answer here is 17,725, and we're going to subtract here 16,000. Pardon me, we're not going to subtract as yet. We're going to follow the principle of PEMDAS and we're going to simply multiply. So negative multiplied by negative is a positive, and we're going to find here that 16,500 multiplied by 0.259 works out nicely to be 4,273.5. That's x squared is equal to, and if we add simply that here 17,725 to the result, then we find that x squared here works out to be 21,998.5. Now quickly, to find x, we find the square root of this value, 21,998.5, and we're gonna find that x here works out to be 21,998.5. X works out to be 148.3 to one decimal place, 148.3 kilometers rounded off to one decimal place. And so therefore this distance between Dark Light Harbor and Star City Harbor works out to be 148.3 kilometers. All right, so that was a really nice question there, guys. Not too tough. A lot of you guys would be able to comprehend that problem. All right, and if it's clear, do not forget to leave a like before exiting from this video. All right, good job there, guys. Let's move right along to question number 2. All right, it says here that we are to determine the bearing of Star City Harbor from Bright Light Harbor. We need the bearing of Star City Harbor from Bright Light Harbor. So from Bright Light Harbor, we want to know what the bearing is of Star City. So from Bright Light Harbor, we want to know where Star City is. So that's an easy question. There's not much working out here because our north line is already at Bright Light Harbor, which is where we're measuring the bearing from. It says from Bright Light Harbor. We want to know where is Star City Harbor. All right, so all we have to do here is just calculate this bearing here. Let's just use purple. We need all of this angle coming all the way around here. Okay, and that's easy because after the little dissections of the angles, we can see that the bearing here is 25. We calculated the bearing here to be 65, and the bearing here is 40. So if we sum those two angles, then the total bearing is going to be 25 plus 65 plus 40, and mathematically that would work out to be 130 degrees. So the bearing, the complete bearing, is 130 degrees, and it visually makes sense. All right, very close to going in between east and south. All right, so not too bad. Comes off a little easy there. Sometimes you get some questions that will spook you, and there are other times when you'll get some questions that will pose a little bit of challenge. All right, next question here is to determine the bearing of Star City Harbor from Dark Light Harbor. So from Dark Light Harbor, all right, let's just get to that. From Dark Light Harbor, this is Dark Light Harbor. From this position here, we want to know what is the bearing of Star City Harbor. So we do not have a bearing, or we do not have a north line at Dark Light Harbor, so we need to establish that. And so we're looking for the bearing coming around to Star City Harbor. So we're looking for this bearing here. Okay, that's the bearing that we're looking for, and that's not too bad. All right, so it's not too bad. We can definitely get some work done here. Let's just have a look. All right, let's have a look. So what I think that we can do here, just to be a little neat, is that we could construct a little south line here. Right, a little south line here, and what that will do for us is that helps us to see the total angle from north to south. So that's going to be 100. So from north to south here, we would realize that angle here all the way around here is 180. Right, so if we can somehow calculate this piece of angle in here, we could probably take that angle away from 180 and we would have gotten the angle on the outside. The total angle is 180, and if we can somehow calculate this angle in here, this little piece here, then we should be able to calculate the one on the outside. But how do we actually go about calculating this little piece of angle here on the inside? So we could perhaps use up some geometry skills here. Let's see. All right, let's see here. All right, this is going to take some work here, guys. This is going to take some work. It's a challenging question here, and so I'm hoping that you're following my thought process. All right, so the only thing that I'm seeing that we could actually do here is that, as you can see here, that the total angle right here, including this little piece in here, is 50 degrees. So I know right away that this angle here, let's just indicate it. So I know for certain that this little piece of angle in here is going to be exactly equal to this little piece of angle in here because of the alternate angle principle. So I know that for certain that those two angles are going to be equal. Now, if I can find this piece of angle here, then automatically I would have found this piece of angle here. And so once I've found this piece of angle here, I can take it away from 180. So that's going to be 180 minus this angle shaded here. And that will give us the total bearing that we're looking for. So everything boils down to us really finding the angle that is all the way down here. Now, the only way to actually find this angle here is to literally find the one that is on the inside. So if I can somehow perhaps say find, let's see if we can find this angle in between here. If we can find this angle in between here, then all I have to do is just subtract that angle from 50 degrees. So if I can find this angle in between here, that's from here to here, I take that angle away from 50 and I would have automatically gotten the rest of the angle here, and then transfer that result up here and take it away from 180. So that requires a deep level of interpretation, guys. So that's what we are gonna have to do. Tough question, guys, but let's get right into it. So lots of analysis required here. So let's go right ahead now and find this angle. And we can easily find that angle by using the sine rule, because this is the angle we're in search of. So this side is known to us, and we already have the 148.3 and the angle that is in front of it. So therefore we could definitely go ahead and use the sine rule here. Before we actually write down the sine rule formula, let's label our sides. We're going to call this side here A. We're going to call this side here A. And then we're going to be calling the angle that we're actually looking for capital A. And then so we're going to be calling this side here B. And we're going to be calling all of this angle in between here big B. So let's go across here and just create some, well, not go across, let's just create some space here. Alright, so the sine rule would have been A divided by the sine of the angle facing small a is equal to B divided by the sine of the angle facing small b. And so we have already established that A would have been 75 kilometers divided by the sine of the angle, which is what we're looking for, which is sine A here. And that's going to be equal to B, which is 148.3 divided by the sine of the angle that is facing 148.3, which is 105 degrees. So let's hop onto our calculators. A tough question, guys, tough to interpret, but once you have gone through the interpretation process and you're practicing a lot, then you're not going to find it very, very difficult with experience. So that's 75 divided by the sine of A, which we are in search of. And that's going to be sine of 105. That's going to be 148.3 divided by 0.965. So let's go here. 148.3 divided by 0.965. We're going to find here that 75 divided by sine of A is equal to 153.68 rounded off. All right, so the unknown variable is at the bottom. Let's not get flustered now and remember. So that's 75, swap position, that's 153.68, and that's equal to sine of A. So let's go ahead here. 75 divided by 153.68, and we get an result of 0.488, and that's equal to sine A. So to find the angle A, it's going to be equal to the sine inverse, or the arc sine, of 0.488. So shift sine 0.488, and we get an angle here of 29 degrees. So the angle that we had indicated to be A is actually 29 degrees. And the total angle we had indicated earlier to be 50. And I hope you can see how our earlier work and our earlier deductions in the problem is now making this calculation easy, because had we not found that 50 from early, we would have been struggling right now to figure out, or assuming that you would have been struggling to know what the angle is at this point. So therefore, this angle here would have been 50, take away 29, and that's giving us a total angle here of 21 degrees. So if this brown angle here is 21, then it means that this angle here is also 21 degrees, which therefore transfers to here to be 21. So our total bearing on the outside here is going to be 159 degrees. All right, and that is basically the deduction of that particular bearing. It's a very tough question, guys. Very, very tough question, but as I said, this is what it takes to really deduce and get your angle. All right, so hopefully you guys really got tuned into that. That took us a good half an hour to go through that problem, but that's what it takes, and hopefully you guys were able to really tap into that particular problem there. All right, so pretty good, pretty good. All right, let's jump to another question. Right, we're really putting in some work, so let's just continue putting in the work here. So we're looking at example number 4, and I do have a few more examples around here for you, but I'm going to make a third tutorial for that one where the diagrams are already drawn for you. So now we're going to be looking at example number 4. An aircraft sets off on a journey with airport equipments from point Z to point Y on a bearing of 45 degrees, which is 96 kilometers away. All right, so we're going to attack this aspect of the problem from early, and let's just set this up. All right, I like the angle 45 degrees. It really doesn't pose much of a problem when it comes to calculation earlier. So let's just later, pardon me, not earlier, later, it won't pose much of a problem. Let's have a look here. It says that the aircraft sets off on a journey with airport equipment from Z, and it's heading towards Y. So let's just put our point Z here, and we're going to establish yet again another north line, and that's 45 degrees. So all we need now is just a guideline of 90 degrees. And so 45 degrees would have clearly been in the exact middle here. Okay, let's just draw it a little bit down. Might end up, so let's just go down a little bit here. That's Z, north line. guideline of 90. Exactly between here. Assuming that y is going to be here, the bearing is 45 degree. Our north line is here, and it had said that the distance is 96 kilometers away. So this distance here would have been 96 kilometers away. All right. So we can actually insert this little piece of angle here, which would have been yet again 45 degree. And as I had mentioned numerous times, that when you find these little pieces of angles early, then later on they are going to play a valuable role when the problem becomes, if the problem becomes a little complicated, like our previous example. All right, let's just go off again now and have a look at the remaining aspect of the question. Now the aircraft is currently at Y. Right, it says after unloading, I'm not sure there's a typing error here, but it says after unloading. Okay, so after unloading the aircraft, it should have been the aircraft, it sets off to point X, which is due east 115 kilometers away. So we had spoke about this whole aspect of an object traveling due east, due north, due south, due west. And so when you see that word due, it simply means that the object is traveling at exactly 90 degrees from its current location. So this here would have been, perhaps say here, Y. And so the object is going to be, obviously, let's just indicate our north line here. And due east is what it said. Correct? Due east. So that would be taking us exactly in this direction here. Okay? Awesome. So right here would have been 90 degrees. And so it's 115 kilometers away. So I think I may need to make an adjustment to my diagram just so that it can be realistic. I'm just going to pretty much make this line a bit shorter. So this is 96. Just to make the diagram realistic. So this is 96 kilometers. And then due east, this is north again. Just a little adjustment, guys. Nothing major. Just so I can make this line a little longer. Here. Just a little longer. Alright. They're not too far apart. 100 and, let me see here. 96 and 115. It's not too far apart. Just 100 and, just 19 kilometers in difference. So that's 115 kilometers. This angle here is 90 degrees. Alright, so just to make the diagram a little more realistic. Okay, alright, and then obviously this is going to be, say here, Y, or this is point X actually, and this is actually Y here. Okay, and so let's see it. Obviously I believe that the object is going to return, the aircraft is going to return, so this is probably going to connect here. When you're doing bearings, remember that the diagram is not drawn to scale, so no assumptions cannot be made without geometric reasons to back up what you're saying. A lot of you guys may think that drawing this line from here in between the 45 would cut the 45 into 22.5 degrees, but that assumption cannot be made without geometrical evidence. Alright, so this is pretty much the diagram that we are working with at the moment. And so here we're looking at the fact that we are to calculate the bearing of point X from Y. The bearing of point X from Y. Again, I think this is a typing error. I think the question should have been the bearing of Z. Let me just go right in here, make that correction. Alright, so that correction is going to be the bearing of say here Z from X. Okay, I think should be the correction, guys. So it's the bearing of z here from x. That's to add some more complexity to the problem, right? We don't want the question to be too easy where we cannot get out a lot of information from it. All right, so that's what we're looking for, the bearing here of z, the bearing of point z from x. So since we're measuring the bearing from x, we need to establish yet again a north line. And the bearing is coming around all the way around like so. All right, so that's the bearing that we're looking for. Now it's on the outside of the diagram, so there's no formula that can really help us, so we may have to use some geometric skills here. Let's just construct a south line here, which would obviously cut that total bearing into a portion that we already know to be 180 degrees. So that there is 180 degrees. So to find the complete bearing, we'll need to find the angle in here. And so we're looking to see if maybe we can find something related to the alternate angle. And yes, we can. We can find that here, that this north line here runs parallel. Pardon me, this north line here runs parallel to this constructed south line here. Okay, so this angle that we're really in search of is going to be equal to all of this angle here, all of that angle here. All right, so we don't have all of that angle indicated by the purple curve here. We only have a partial amount. We only have the 45 degree. All right, but what we can do though is that we perhaps could be able to find, we could perhaps find the angle here in between. If we can find the angle in between here, that is this distance right here to here, then we could pretty much add that angle to 45 and we'll get the total angle marked by the purple curve. And so finding that total angle here would therefore find this angle out here, which we would therefore add to 180 degrees to find our total bearing. So we need to go in search of this particular angle here. All right, now let's see if we can actually use something to our advantage here. All right, we're gonna have to do some work here, guys. It's gonna take another level of interpretation. If we were to perhaps say construct a south line here, then again we would construct a 90 degree here. And then the thing is that there is no actual formula that we can use to find this angle. We do not have enough information. Number one, cosine rule cannot be applied to find the angle, because the angle that we're trying to find is not in between the two known sides. So that's where the problem lies. And we don't have all three sides to find this third side here where we could apply the cosine rule to find this angle. So that's a problem. So I think if the cosine rule is not applicable, then we're looking at finding this using the sine rule. Now the sine rule, to use the sine rule, we're going to need the side facing the angle we're in search of, which we do have. We have the 115, but we don't have an angle that's facing another side. We don't have this angle here. We don't have this angle here, but we could find it. Let's see here. This is a tough question. I think I may have constructed the question tougher because I haven't looked at the question prior to the video. So we're going to need to put in a lot of work here, guys. Let's see. I think perhaps maybe whilst constructing the question, I should have perhaps asked you to find the distance of xz first. That would make it a lot more realistic. But either ways, we would still have to find the distance of xz. So we may have to do some work here, guys. We are going to need to find the distance of xz here to go somewhere. So we need an angle in between here. So this angle here is going to be 45 because once again, it is alternate. It is alternate. So it's going to be this north line here forms an alternate angle with this constructed south line. So this 45 here is equal to this 45. So the total angle between here is actually 135 degrees. That's 90 plus 45. So the only way to really find this particular angle here would mean that we'd have to find this side xz. We can find it because we have the cosine rule to our aid. So let's go around here and try to find the cosine rule. Just gonna hop on this blank page here. So the cosine rule here is that c squared is equal to a squared plus b squared minus 2ab times the cosine of theta. So c squared would have been naturally the side that we're trying to find here. It's a tough question, guys. I think I may have asked you to do a bit too much in the initial stage. I think an appropriate way to write this question would have been asking you to find xz first, which is naturally what we're going to be doing here. So xz squared is going to be equal to the sides that were given to us here were 96 and 115. So that's 96 squared plus 115 squared minus 2 times 96 times 115 times the cosine of the angle between which we had deduced to be 135 degrees. Lots of work to do, guys, but let's get into it. 96 squared, that's 9,216 plus 115 squared is 13,225 minus 2 times 96 times 115, that's 22,080, and the cosine of 135 would have been negative 0.707. So if we add and multiply, so that's 9,216 plus 13,225, we get 22,441 minus 22,080 multiplied by 22,080 multiplied by 0.707. We know that negative times negative is a positive, so that's 15,610.56. And if we add those two together, 22,441, we get a distance here, we get a total value here of 38,051.56. So that's xz squared, xz squared, that's xz squared equal, so xz then would have been equal to the root of 38,051.56. so shift square root 38,051. My calculator here, guys, I have to insert shift to activate my square root, so don't mind that. You should have a square button on your own. So that's 195. It's 195.07 rounded off to 2 decimal place. That's kilometers. Alright, so this distance around here is calculated to be 195.07. Alright, so I think that would have been an appropriate question to really ask you to calculate first, and then after asking you to calculate that, then naturally I could go ahead now and perhaps ask it to find the bearing of z from x. So now that's what we're going to be finding. So you would have gotten some marks. It would have been about 3 marks to find that particular side and another 3 marks to find this angle here. So now we can clearly use the sine rule now, because we have a side and we're looking for the angle facing one of the sides that we know, and now we have calculated the 195.07 and we have the angle opposite to that. So we could therefore go ahead and use the sine rule to our aid here. Alright, so let's just create some space here, guys. So hopefully you guys have that calculation pat down. So we're going to go here and we're going to find the sine. We're going to be using the sine rule. So that's going to be A over the sine of capital A is equal to B over the sine of capital B. And let's just indicate our A and B from now. So we could use here that this is going to be A. Okay, this is going to be A. And that's going to be the angle indicated by the A, capital A. And this is going to be B, capital B. So 115 divided by the sine of A. So that's 115 divided by the sine of A. And that's B, which is going to be 195.07 divided by the sine of the angle, which is 135. So it's 115 divided by sine of A is equal to the sine of 135. That's 0.707. So that's 195.07 divided by 0.707. Alright, so 195.07 divided by 0.707. We're getting an answer here of 115 divided by the sine of A is equal to 275.91. And if we swap position, then we'll find that sine A is going to be equal to 115 divided by 275.91. So we'd end up with sine A being equal to 0.416. So A is equal to sine inverse 0.416. A is equal to 24, approximately 25 degrees, rounded off to the nearest degree. So that's 25 degrees. All right, so that was a lot of work, but let's just get into it. So this particular angle here, inside here, is 25 degree. Inside here is 25 degree. So this total angle that we have here is going to be 40 and 20, that's 60, and 10 more, so that's 70. So this total angle coming around here is about 70 degrees. This angle would have been obviously 20 because the full angle is 90, and we just calculated 45. This is from black here, 45. We just calculated this to be 25, so that angle is 70. So this angle here is also 70 degrees because of the alternate principle. So therefore the total bearing then that we are calculating here is 180 plus 70. So that total bearing here works out to be 250 degree. All right, tough question, guys, but it will help with a lot of your interpretation. If you're able to navigate your way through a problem like this, then you're going to find that a lot of the problems that are presented when it comes to cosine and sine rule in trig is not going to be much of a problem. So tough question, but we were able to actually deduce and get ourselves through that problem. So this would probably value about 6, maybe 7 marks, but I doubt if CSEC is going to structure the question in that way. All right, but hopefully I was able to actually walk you through that problem without much of an hiccup. All right, and finally here we're to determine the distance of point Z to X. So point Z to X, you can clearly see that this question is what I should have written first, and then this question last. I think I made a typing error in terms of the question that should have been calculated first, because as you can see here, guys, you can clearly see that we had initially, I had erased the information around here, when I had calculated using the sine rule, the cosine rule, I had automatically calculated the distance of x and z, or the distance between point x and point z. So we had already calculated that to be 195.07. So hopefully you guys saw that the error made in this question was in terms of putting this question first and doing that question last. All right, so good. I hope that you guys were able to follow each and every step. In the event that you got a little confused, feel free to rewind the video and have a look and follow as we go along, and ensure that you have your calculators at hand working with me to see if there's any errors that may have been made, and let me know in the comment section below. All right, so this wraps up our concept as it relates to bearings. Tougher questions than these you perhaps won't be able to find unless you're going higher up in math. But for the most part, these 4 questions in part 1 and part 2 really covers a lot of what's related to bearings and its application. All right, couple more videos on triggers coming out, so do stay tuned for that. But we're going to be diving into our other tutorials: circuit theorem, circuit geometry, and the transformation geometry. So be sure to subscribe to the channel, leave a like, leave your comments, suggestions, and video requests down below, and check the description box for links to other useful tutorial videos. Do take care until next time. Bye bye.